Alrighty, so today we are talking about half reactions in galvanic slash, that's not right, electrolytic cells. Okay, so everyone has most likely heard or done redox reactions. Okay, reduction is the gaining of electrons, gains of electrons. Trying to draw. So it's a muscle. Someone showing off their bicep, getting gains, reduction and oxidation is the loss of electrons. Okay, so let's say in a galvanic cell, we already know galvanic cells are spontaneous, meaning excuse me, that they have a K above 1 and their delta G is less than 0. That's right, less than 0. Now their cells, or their reactions, have a thing, well, so do the electrolytic cells, but galvanic and electrolytic cells have a term called cell potential. Okay, and that cell potential for a galvanic cell will always be positive. Okay, so let's take, for example, the cell here. Okay, we've got a cell with iron 2 and zinc. Or no, not zinc, sorry, copper. Okay, so we've got iron 2, copper 2, and they're going to undergo a redox reaction. Now, each one of these half reactions we have to write out. So iron 2 plus gaining 2 electrons, it's a lot easier to write it this way, gives iron solid. Okay, this is what's called a reduction potential. Okay, these reduction potentials are their half reactions written out as reduction reactions. So gaining electrons, getting them gains. Okay, it's a reduction potential written out like this, and each one, I believe purple was the iron, each one has a potential, not a cell potential, but a potential for the reaction. Okay, now the potential, the reduction potential for iron 2 is negative 0.45, and the reduction potential for copper 2 is 0.34. Okay. Now, if these two metals were to form a galvanic cell, then its total cell potential would have to be positive, right? So what we have to do is we have to rearrange these equations to give a positive E cell, a positive cell potential, when we add these two numbers. Okay, the only way to do that would be if we flip the, I believe it's the iron, right? Yeah, if we flip the iron, okay, we also need to make sure that the electrons are not on the same side, because you can't just have both reactions going on B reduction. Okay, if you do that, then you're pulling electrons out of nowhere. Okay, so what we're going to do is we're going to flip the iron reaction, and that iron reaction is now going to be Fe solid yields Fe2 plus 2 electrons. And we still have our regular Cu2 plus 2 electrons gives Cu solid. When we add these two together, we get iron solid plus Cu2 plus 2 electrons gives copper solid and Fe2 plus and 2 electrons. Now, at this point, we need to make sure that the electrons cancel out. Okay, if we cannot cancel out electrons, then we have to put coefficients in their half reactions to make sure that we can. Okay, in this case, they both have 2, so we can just go ahead and cancel out those electrons, and what we're left with is their reduction reaction, or their redox reaction. Now, we had to flip the iron reaction for us to get a positive cell potential. That's what I was thinking of. Okay, and what we do to that E value is we just change the sign. Okay, 0.45. It is now positive instead of negative. And when you add them together, you get a total cell potential, E cell, is equal to 0.79. And these are in volts, okay? These are in volts. Excuse me. Okay, so I'm going to write out the steps you need to know about finding cell potential here. So, make reduction half reactions and find their potential. Okay, that's step 1. Step 2, determine if it is a galvanic / electrolytic cell. Flip half reactions accordingly. Coefficients to cancel out electrons. That's a 5. And then add redox potentials to get total cell potential. Okay, that's all we did. Okay, we knew we were working with iron 2, copper 2, so we wrote out their reduction potentials here. Okay, the reduction potentials have these numbers. Then we figured out that we were working with a galvanic cell. So when we flip our half reactions accordingly, we had to make sure that our E, our total value, when we added them together, would be positive. Okay, that told us which way we were flipping, or which reactions we were flipping. Coefficients to cancel out electrons. We need to make sure that our number of electrons cancel out. And if they don't, then you have to put coefficients in the half reactions to make sure that they do. Okay. And then finally, you add their redox potentials, like we did here, to get the total cell potential here. Okay. Let me check my notes. Cool. That is it. Okay. Now, it is not always going to be nice metals. Okay? It's not always going to be like unbonded metals. Okay? It can also be metals that have bonded to something else, but there's still a reduction reaction going on. So make sure you are keeping a lookout for redox reactions. Okay? Keeping track of which one is the oxidant, or sorry, which one is going through oxidation, which one is going through reduction. Okay? All right. Watch the video, take some notes, ask me if you have any questions.